This question was used to test the brightest 16-year-old math students in the UK on the Maths Olympiad. So would you know how to go about solving it? It's a simultaneous equations question. So the general technique that you have learned is to rearrange one of the equations and then substitute into the other one, which we can go ahead and do that here. The only difference is we've got a cubic equation here, which is going to make it a little bit more difficult, whereas normally you'd have a linear or a quadratic simultaneous equation. But let's go ahead and do it. So we can rearrange the first equation to y equals 3 minus x. And then we can substitute that for, well, we can cube it and then substitute it into the second equation. So let's cube it first, just to make those steps nice and clean. So we can either expand this into multiply two brackets together and then a third one, or we can use the binomial theorem. If we use the binomial theorem, we get 3 cubed, which is 27. Then we get 3 times 3 squared times negative x, which would also give us minus 27x. For our third part, we're doing 3 times 3 times minus x squared. So that's going to give us a plus 9x squared. And then for our last part, we've got minus x cubed. I'm just going to write that below. So we know now what we need to substitute in here. We can see that the minus x cubed and the plus x cubed is going to cancel. So we're just going to be left on this side with 27 minus 27x plus 9x squared is equal to 9. We can subtract 9 from both sides and we can see that there's actually a multiple of 9 here. So we're going to be able to divide in just a moment. And what's nice here is it gives us a nice simple equation that we can factorize and solve. So we get our solutions x equals 2, x equals 1. To find our y values as well, we can substitute back into the simpler of the two equations to get y equals 1 or y equals 2. Now you may think, actually, I saw that right at the beginning without having to do any of this work. Even if you spotted that from the first two equations, you still need to go through the algebraic method to show that there's not other possible solutions as well. So that is your final answer. I hope you liked it.